Alright everybody, first video didn't work, something about the audio, so I'm going to try to re-record this. Hopefully it works this time. So try to do pretty much the same thing I did the first time, but here we go again. That was my fault. So anyway, so to start off today, kind of review some of the reflection algebraic rules. And what happens when you reflect over the x-axis, reflect over the y-axis. And what if you don't have a graph? Alright, so what I'm looking here is I have a reflection over the x-axis. So just kind of a refresher, when you reflect over the x-axis, that's going to be an up, down, flip. But we're looking more at what's the algebraic, what happens to coordinates when you do that. So when we flip over the x-y axis, or the x-axis rather, it's an up, down, flip. So think about it, I got a point up here, and I'm flipping down there. So what's happening is, you'll notice it's still on the same positive x side of the axis, so the x coordinate stays the same. But what did switch was, if it was started up at the top, at the bottom, you have the y coordinate flip sides. Because if it was negative, it would turn into a positive, positive, it would turn into a negative. Alright? So then, let's look at the algebraic version of this one. So we're going over the y-axis. That's going to be a left, right, flip of the y-axis. So if I have this point here, and I reflect it across the y-axis, it's now heading over here. So what started as a positive x, positive y, you'll notice that I flipped to a negative x side, but I remain on that top side with that positive y. So it's kind of a reverse thing. So if you're flipping over the x-axis, the y switches signs. If you're flipping over the y-axis, it's that x coordinate that changes signs. So if we look at it with just numbers, right, what's happening here? So we're going over the y-axis, so that means that's our reverse thinking. So that means my x coordinate is going to switch signs. So starting as a negative, that means it's going to flip to a positive, and nothing happens to the y coordinate. So then the same is true for the second one, but this time I'm going over the x-axis. So when you go over the x-axis, the x coordinate stays the same, but the y coordinate here, that's a flip of signs. Alright, so you can do that without having to have a graph at all. Alright, so these two are going to be on your own. So what I want you to do is I want you to do them by yourself, pause the video, and come back. Alright, welcome back. So what we have is we're over the y-axis, that's a switch of the x coordinates, -4 over 2. And for the second one is a flip over the x-axis, so that means the x coordinate stays exactly the same. The y coordinate switches to a positive number in this case. Alright? So what would happen if I don't have points at all and I just have letters? A, B over the x-axis. Our rules still apply. So when I go over the x-axis, that's my y coordinate changing. So that means the A is my x coordinate, so it's my x value, so nothing's happened to that. But this B, being the y coordinate, will flip this sign. So A negative B would be what happens here. Alright, for the next one, same deal, except I'm going over the y-axis. So whatever the x coordinate is, that's going to switch signs. Well, in this case, it's positive a, so I'm going to change it to a negative a, and nothing happened to the y coordinate. Alright? Alright, so now, moving on here, how to tell the difference between a reflection and a translation. Alright, because sometimes it's easy to see them, sometimes it's a little bit more challenging. Now, instances like this, a little bit more challenging because the shape is pretty much the same thing. And that's where you have to look at the letters. Alright, the letters, the labels. So I got to look at my A, my B, my C, my D, and I look at, so my old shape's on the left here, so I'm going to label it O, and my new one, the prime one's on the right. So you might see this one as your pre-image, and the other one as your image or the prime. And what matters is I got to look at the letters. All right, I got to look at the letters here, and I got to see, okay, if I look at the shapes, okay, they look the same, but all the coordinates are the same. But it's the letters that matter here that help us recognize what's happening. Because I know that in the translation, the shape's just slid. So that means whatever way it's facing is going to stay the same way. And so that means if A is my original and it's on the left, if if I translate this thing, it should stay on the left. But when I look at it, oh, A is actually on the right side. So that's a clue that this thing has been flipped. It's been reflected. All right? So the letters matter here. Now, for example, if I saw this, I say, okay, I look at my original, I say, oh, A's on the left. If I come over here, A's still on the left. That's an indicator that a translation happened. So that's still that same idea of flipping is something that you got to look for, right? Even if you can't tell by the shape. A lot of times you can just see the shapes being flipped. You know, it's a pretty obvious thing. If it's facing the same direction, that's a pretty easy translation. But if it's an obvious flip, then you can say, okay, that's a reflection. But in cases like this, where you got to look at the letters, you know, look and see what the letters did. How did they behave? How did they act? All right, so what we're going to do here is we're going to look at some fake test questions as well. And we're going to see, okay, what are they asking you to do? So I've got line segment FG begins at points F negative 2, 4, and ends at point G negative 2, negative 3. So let's find those points here. Negative 2, 4, 1, 2, 3, 4. There's F, and G is at negative 2, negative 3, negative 2, and there's G, and there's line segment FG. All right, easy enough. The segment is translated, so I know translated by x equals negative 2 to negative 3, y plus 2. So negative 3 on the x, that tells me that's left. Plus 2 on the y, that tells me it's going up. And then reflected. Reflected across the y-axis, that's going to be a left-right flip. All that's going to happen here. Form line segment FG prime. How many units long is line segment FG? Well, folks, they're actually kind of trying to trick you here. They're making you do a whole bunch of work that you don't actually have to do. Because here's the thing that we know. I know if I translated, I've got congruent shapes. And congruent shapes, all the angles are the same, all the side lengths are the same. Now, obviously, with this line here, you don't have any angles, so we're not worried about that. But I know the lengths are the same. But then I also know when I reflect something, that's also congruent as well. So that means I can actually do whatever I want for this line, no matter where I move it, because the two transformations I'm doing, the reflection and the translation, everything's congruent this entire time. So whatever size this thing starts at, it's going to end at that size. So if I just count this thing, it's 7 units long. And no matter what I do to this thing, if I reflect and translate, it's going to stay 7 units long. So we can translate, you can reflect all you want, but the start shape and the end shape are going to be congruent. They may not be facing the same direction, they may not be anywhere close to each other, but they are congruent. Alright, so let's look at another one. It says, company created a logo using 2 hexagons as shown. Hexagon PQRSTU is a translation of hexagon A, B, C, D, E, and F. So what I want you to do is, the question is, what is the length of line segment TS? So I want you to pause the video, and I want you to write down an answer. Alright, how long is TS? Go ahead and pause now. Alright, welcome back. So, how long is TS? Well, we got to do a matching game here. And you'll notice PQRSTU, whatever order they put it in to begin with, you're going to have the matching same order here. So that means whatever's first in this line matches with the point that's first in that line. So P matches with A, Q matches with B, C, and so on and so forth. So when I want to figure out how long is TS, I say, okay, what does it match with? So TS matches with D and E. Well, here's D and E. So remember, these two things, because they're translated, and translated congruence, And that means that however long this is the exact same. So that is also 4 as well. Alright, the next one. So, I forgot to erase this, but let's look and see how this works. So it says quadrilateral MNOP is reflected or line translated up. So the reason why I underline these two things is because they are congruent. Reflecting, translating, congruent. And when we say something's congruent, that is angles and sides are equal. So when I did this, I looked and said, okay, if I know angle N is 130 degrees, well, X is the exact same location as that 130 because these things are reflected and translated. So here's X. And let's just say I move the whole thing. Take that shape, translate it, and then I reflect it. So flip is another way to say reflection. And I matched up. There's that 130 right there with that. So those two angles are 130. So the angles still match up. All right. So I hope this one works. If not, please let me know. Anyway, have a great day. Look forward to seeing you folks on Monday.